Okay, the reverse process of a derivative is called an antiderivative. I typically refer to them as integrals, and in this case they're going to be indefinite integrals. So a function with a capital letter F is the antiderivative of the function with a lowercase letter f on a specific interval. And it's giving you the notation, if the derivative of f prime of x is equal to f of x for all x, and that just goes along with this. Don't get bogged down with uppercase and lowercase. It can change for every problem. But what you do need to understand is that you have, if you take the integral of a function, you're going to get back to the antiderivative. If you take the derivative, you can check it. And some of the vocabulary that comes along with this that I'll use, and you need to be familiar with, the integrand is just the expression that you want to integrate. The variable of integration, the examples I'm going to do use x, so we're doing a dx. You can use theta, you can use r, you can use s, you can use t, any variable can be used. You're going to have to use a constant of integration, and that's because when you differentiate something, it's a specific answer. But when you take the integral of something, there are infinitely many answers that are possible, and I'll explain that. But this constant of integration is extremely important. The antiderivative is the result of integrating. Later on, we'll get into solving an indefinite integral, and it's when you're given an initial condition. And then we talk about integration and differentiation are inverses. And it's important that you understand differentiation to be able to do integration. And it has been a while. We've been focusing on so many other aspects of this course that we've not talked about differentiating. And even as we start doing this, you're going to start second guessing or making small errors on your derivatives just because now you're going to be integrating. So on the back of your notes, I have a ton of formulas. The left-hand side is the differentiation formulas. The right-hand side is the integration formulas that go along with it. And you'll notice I don't have anything across the derivative of natural log or the derivative of a log because you don't integrate those. And we'll talk about those later on. And the trig functions are also there. This is a lot, but you are expected to memorize all of these. So let's just talk about a couple of them. If you want to differentiate a constant, you get 0. So if you integrate 0, you get a constant. To me, this makes sense because if you take the differentiation of something, you get the slope of a tangent line. So a constant is a horizontal line, so its slope is 0. If you go backwards and you want to find something that has a slope of 0, it can be any constant. If you differentiate a linear term, you just get the slope. But if you did integrate a constant, you're going to get the slope of the line plus any kind of transformation that has occurred. And I will explain it during the live lesson in more detail, but I do want to work through a couple examples on here. All of these are going to use what's called the power rule, because the other integration problems are really a matter of memorizing. These take a little bit more thought in them. So if I want to integrate this polynomial, x squared plus 3x minus 2, I'm going to break it up. I'm going to have x squared dx plus the integral 3x dx minus the integral of 2 dx. And you're not going to need to do this every single time. I'm just doing this for the first example. So I can break this up even further. I'm going to say the integral of x squared dx. 3 is a constant. I can bring that out front. And negative 2 is a constant. So now let's look at what happens on the back of your sheet. Like I said, this is called a power rule. Here's my power rule with differentiation. Here's the power rule with integration. So what's going to happen is if you're integrating something x to the n power, you're going to add 1 to the exponent and divide by n plus 1. Which when you differentiate, you multiply by n and you subtract 1 from the exponent. So let's show you how this works. So when I differentiate x or integrate x squared, I have to add 1 to the exponent of 2. So it's going to be x to the third, and I have to divide by that exponent. So x to the third over 3 plus 3. When I integrate x to the first power, so I have to add 1 to the 1, so I have x squared, and I have to divide by 2. When I differentiate just dx, I'm going to get x. And then always add c, your constant. Do not wait till the end and put the c in at the end. Get in the habit of doing it right as you go along. And this is an acceptable answer. I prefer myself to write 1/3 x cubed plus 3 halves x squared minus 2x plus c. And I can check that by differentiating, and I really recommend it because it's very easy to make a simple mistake. So when I check, 3 times 1/3 is 1, so I'm going to have x squared. 2 multiplied by 3 halves is 3, and then minus 2. And I check that against what I started with my integral, and that's good. So that checks. My next example, I'm going to rewrite this. I'm going to write this as the integral, well, let's do it this way, 1/5 the integral x to the negative 2 dx. I like doing it that way. I get rid of the number. Then I'm just going to worry about integrating this x to the negative 2 power. So this is going to be 1/5. Add 1 to negative 2 gives me negative 1. And I'm going to divide by that. Right away I'm going to do plus c. So you can leave this as negative 1/5 x to the negative 1 plus c. Or you can do it as negative 1 over 5x plus c. To me, it's easier to check this one here. Negative 1 multiplied by negative 1/5 is a positive 1/5. Subtract 1 from negative 1 and I get negative 2. So I get back to that. So either one of these, whichever you prefer, is fine. And that one's not a polynomial. That's a rational expression, but it's still, the power rule works with it. This next one, I'm going to rewrite it as the integral of x to the 2/3 dx minus the integral of x to the negative 1/2 dx. Once again, this is not a polynomial, but because you have exponents, we can use this power rule. So I'm going to have to add 1 to 2/3. So this is going to be x to the 5/3 divided by 5/3. Minus when I add 1 to negative 1/2, I get a positive 1/2 divided by a positive 1/2 plus c. And I'm just going to rewrite this. When I divide by 5/3, it's the same thing as multiplying by the reciprocal. So 3/5 x to the 5/3 minus 2x to the 1/2 plus c. And I would check by differentiating. 5/3 times 3/5 is 1. Subtract 1 from 5/3, and I get 2/3. That's what I've got here. 1/2 times -2 is -1. Subtract 1 from 1/2, I get -1/2. That's what I have here. So that's the answers.